Let's start with a basic question. When do we say that two sets are equal? In everyday life, if two boxes contain exactly the same items, we call them equal. In set theory, the same logic applies. Two sets are said to be equal if they contain the same elements, no matter the order and no matter how many times each element appears. It's not about how a set looks, it's all about what's inside. Mathematically, sets A and B are equal if every element of A is in B and every element of B is in A. In set theory language, we say A equals B if A is a subset of B and B is a subset of A. It's a two-way relationship. Here's an example. Let set A be 1, 2, 3, 4 and set B be 4, 3, 1, 2. Even though the elements are in different order, both sets contain the same elements. So we say A equals B. Here's something important. Repetition doesn't matter in sets. If set C is 1, 2, 3 and set D is 1, 1, 2, 3, 3, then sets C and D are still equal. That's because we only look at the distinct elements. In set theory, duplicates are ignored. We only care about unique values. Let's try a visual approach. Imagine two transparent jars filled with colored balls. If both jars contain one red, one green, and one blue ball, even if they're arranged differently, the jars hold equal sets. That's the idea of set equality. The order doesn't matter. Repetition doesn't matter. Only the collection of distinct elements counts. Let's look at some clear examples. Example 1. Set P is my 2, 3, 5, 0. Set Q is my 3, 5, 2. P and Q are equal. Same elements, different order. Example 2. Set R is defined as the set of all prime numbers less than 6, which gives na 2, 3, 5. Set S is the set of prime factors of 30, which is also 2, 3, 5, so R equals S. Now a non-example. Set T is 1, 2, 3, 4. Set U is 1, 2, 3, 5 here. T is not equal to U because 4 is in T but not in U and 5 is in U but not in T. Understanding equal sets helps us compare data spot matching patterns, simplify solutions, and check for correctness. This becomes essential in many areas like functions, subsets, and logical reasoning, where comparing sets is part of the process. So always remember, two sets are equal if they have the exact same unique elements, regardless of order or repetition. Now that you understand equality, let's move on to the next big question. What if one set is inside another?